another univariate plot function, which is quite important, is the boxplot. And of course, we use the boxplot function. We have data, for example, square meters. And we see here that we have the minimum, the maximum, and then we have the average here, and the percentiles here and here, the 25th percentiles and the 75th percentile. So we see that it's a right skewed distribution here. So, and these dots, they may indicate that there are outliers in your data, but I'm just emphasizing may. And to make this box plot a bit more interesting, we can use some more, not price, square meters. We can add some information to it. So we have a main, which a plot always should have. For example, square meters. We can change the color. And here I'm going to choose a hexadecimal color that I've looked up. 6744 AD, which is that one. And you should always pick a color which suits the needs of your client or your company. And we can make it horizontal, and we can make a notch like so. And what we get then is this notch here. Well, that was no success, so we just remove that. And we have a box plot here. The good thing about box plots are that you can find these outliers here, and also that you can stack multiple box plots. So for example, we can make a box plot with data and square meters. And for example, this would be for data city equals Oslo, for example. And we can have data, well, actually, we can just do this. And then we have city equals Trondheim. And then the main could be square meters again. And at defines where the two different data should be at. So we are putting the first one, Oslo, at first place here, and Trondheim in second place here. And then we can have names, and that would be Oslo and Trondheim. And then we have to do like this. using the concatenation function again. And let's see, color, we can have two different colors on the two different plots. For example, we can have, well, what we have above here, and a new one. For example, let's see how this will work. 9F44AD. Okay. Yep. Not totally bad. Horizontal equals true. Okay, let's see how this goes. Okay. Let's see, boxplot data square meters, data city equals. What did I? Noob mistake. When you're testing if something is true or false, then you have to use the double equal sign. Okay. So here we have, oops, square meters. Should be like that. Okay. So square meters for Trondheim. Oslo at. Yeah, well, that should be okay. Because Trondheim has larger apparently has larger what's the word, apartments in this data set. So and the second one, or the last one I want to show is that you can quite easily do these comparisons with the price on city. So this is kind of an equal sign, but here it means that we are looking at price, but we are grouping on city. And data should be the data frame, which is called data. So here we have not added any color to this, but here we are looking at price, and you can see the difference between Oslo and Trondheim. So that's a quick way to group by city, for example.